we spoke about surds on the last lesson, so we want to talk about how we can actually work with surds, okay, and rationalize surds. Let me just write here. Okay, now if there is a single term surd in the denominator, we can actually rationalize it by using, the following steps. We can actually multiply the denominator. Let me just multiply the denominator by itself. Okay, that's step 1. And then we can multiply the numerator by the same term that you multiply to the denominator. Alright. Oops, spelling error. Not good. Denominate. Alright, there you go. Okay, so step 1, you actually multiply the denominator by itself, and you actually, step 2, you multiply the numerator by the same term used to multiply the denominator. So if you had a over square root x, okay, you can write this as a. If you want to rationalize this, let me erase this dot here. Let me try to be neat. Okay, you can write a over square root x times square root x over square root x. Now this is simply a matter of manipulation. Now if you realize square root x over square root x is equals to 1. Okay, how this helps is give you something that you can actually work with. You get a square root x over, now square root x times square root x is equals to x. Right, so it's actually easier to work with a denominator that is not of a root nature. Alright, now this is really an oversimplified example of how you can rationalize surds. Okay, and you're only rationalizing it with one term. Alright, now let me give you another scenario. Let me move down the page here. Okay, now we're trying to rationalize surds with denominators of 2 terms. Okay, rationalizing denominator with 2 terms. Okay, so the first step is actually to multiply the denominator by its conjugate surd. Okay, you know what I mean in a moment. Just bear me. Multiply the denom by conjugate surd, and step 2, you multiply the numerator by the same term you multiply to the denominator. Alright, multiply the numerator with the same term, as in oops, okay, multiply the numerator with the same term as in step 1. Alright, so if you have a over root b plus root c, if I were to rationalize this, let me move down to the next page. Okay, a over root b plus root c. Okay, you can actually write it as a over root b plus root c. Okay, by conjugate surd, I mean root b minus root c. You notice the sign here, the denominator is plus, and hence it's minus here. Okay, and then the numerator you multiply by the same term. Okay, and then you get a bracket square root b minus square root c. Let me erase that, it's quite untidy. Okay, you get this in the numerator. Now, how do you multiply these two denominators here? Now, I wonder if you actually remember the identity a plus b, a minus c is equals to a squared minus b squared. Can you see this resembles a plus b right here times a minus b? Alright, it's actually in this form. So what you can do is take square root b squared minus square root c squared. You get a root b minus root c. Since you square root b, you get b minus c. And that's your answer. So with that, okay, if you actually understand that, you've just learned how to actually rationalize surds, okay, that have two terms in its denominator. Now, if you don't understand this, root b squared is equals to b. Why? Okay, because root b is actually b to the power half, okay, squared. Now, if you remember one of the laws of indices, a to the power n bracket to the power n is equals to a to the power mn. Okay, this is the same thing. All you have to do is take half times 2, okay, and you get b to the power 1. B to the power 1 is just b. Okay, so probably skipped a few steps there. Okay, made an assumption that you already knew, but for those who don't know, just remember that, okay, with surds you can actually use the laws of indices as well. Alright, so with that, this is Kingsley just signing off here. Study well, study hard, and thank you for listening.